Hello, Math 201. Today we get to go over section 3.7, the chain rule, which is another differentiation technique that's a little bit more complicated than the others. And so we'll spend a little bit of time on it today. And hopefully with the homework, you'll get a better feel of it. So let's remind ourselves of what we're able to take derivatives of so far. So we know how to take derivatives of polynomials, right? So any polynomial, we can take the derivative just using kind of the sum rules, power rule, and we can do that. We know how to take the derivative of e to the x, trig functions. I could also add natural log to this, ln of x. We know how to take the derivative of that guy too. And then we also know how to take the derivative of sums, products, and quotients, right? Derivative of sum is derivative of f plus derivative of g. Derivative of the product of the two is f prime times g plus g prime times f. And the derivative of the quotient is g f prime minus f g prime over g squared. But what about a function like this, where we have 5x plus 2 composed with cubing, right? So you take this function 5x plus 2 and then you cube it. So that's not a sum, that's not a product, it's not a quotient, it's what's called a composition. And I guess we could expand it out, right? You could just FOIL it out and then take the derivative like a polynomial. But what about if you had something like that? 5x plus 2 to the 100th power. Now foiling it out is not going to work. I mean, that would just be way too big. And so we need another way. And so this is where the chain rule comes in, when we have composition of functions. And to kind of motivate it, here's a silly example. So let's say we have three people, Yancey, Yuri, and Jan. Yancey is 3 times faster at picking apples than Yuri, and Yuri is 2 times faster at picking apples than Jan. And so how much faster is Yancey than Jan? Well, it's 3 times 2, so he's 6 times faster. And so if we let dy be the rate of Yancey, du be the rate of Yuri, and dx be the rate of Jan, how much faster is Yancey than Jan? i.e., what is the ratio of the rate of Yancey to the rate of Jan? So dy over dx. Well, dy over du, so the rate of Yancey over the rate of Yuri is 3, and the rate of Yuri over the rate of Jan is 2. And so dy dx is dy du times du dx, which is 3 times 2, which is 6. And so this right here, that is the chain rule. And it almost looks like they're kind of fractions that cancel, right? dy dx is dy over dx because the du's cancel. But caution, dy dx isn't technically a fraction, right? dy dx is a derivative. It is saying take the derivative with respect to x of y. But pretending it is helps us to remember the formula by canceling the fractions. And so you can think about them kind of like canceling fractions, but remember they're not actually fractions, they are derivatives. But thinking about them as fractions helps us to remember the formula. And so using the fact that y is a function of u and u is just g of x, then written as a composition, we have this. Y is equal to f of g of x, right? So u is our new variable, but u is also a function of x. And so plugging in g of x into f of x, we get y is f of g of x. Because u is g of x, then d dx of u is the d dx of g of x, but that's just g prime of x. And so putting that all together, dy dx is dy du times du dx. But that means that y prime is equal to, well, dy du, if we take the derivative of that with respect to u, that's just f prime of u. And then du dx, well, du dx is just the derivative of u, which is u prime. Now replacing u and u prime with g of x and g prime of x, we get that y prime is f prime of x, f prime evaluated at g of x times g prime of x. And so here it is, the official chain rule. So this is equation 1 and equation 2. So dy dx is dy du times du dx, where u is the inside function, g of x, and y is f of u, where f is the outside function. Written another way, d dx of f of g of x is f prime of g of x times g prime of x. We call f of u the outer function, and u, g of x, is the inner function. And so you can think about the derivative of a composition is you take the derivative of the outside function, evaluate it at the inside function, times the derivative of the inside function. And so when we use the chain rule, you identify the inner and outer function, and you let the inner function be called g of x. And then you replace g of x with u to express y in terms of u. So y is f of u. Then you calculate the product, dy du times du dx. And then you replace u with g of x and dy du to obtain dy dx. So that's kind of the long way to do it. And we'll do a couple like that. And then I'll show you kind of a shortcut when you get more comfortable. But let's do it the long way. So doing this the long way. So what is the inside? So what is the inside function? So g of x is the inside function. The inside function is 5x plus 4, right? And so then what is u? So that's going to be u. U is g of x, which is the inside function. What is f of u? F of u is plug in u for g of x. And so that's what y is. Y is f of u, and it's u to the 3/2 power. Now we're going to take dy du. What is dy du? Well, dy, if I take the derivative of this function with respect to u, that's going to be 3/2 u, and then 3/2 minus 1, which is 1/2 power. So that's dy du. And then what is du dx? Du dx is take the derivative of this function with respect to x. That's going to be 5. And so that means that dy dx is equal to 3/2 u to the 1/2 times 5. But now plug back in g, and so that's 3/2. And then what is u? Well, u is 5x plus 4. And so it's 5x plus 4 to the 1/2 times 5. And then you can just leave it like that. We could simplify by bringing the 5 out, but that's fine. Let's do all three of them, actually. So let's do B as well. So here's part B. So y equals sine cubed of x. What is the inside function? So g of x, in this case, the inside function is sine of x, right? That's what we're plugging in on the inside. And so that's u. U is that. What is y? Y is f of u, which is u cubed, right? Because sine is being plugged in, and so we're taking 3u to the 3rd power. And so then u prime, which is du dx, is going to be cosine of x. And then y dy dx, maybe I should call these du dx and dy du. So this is dy dx, du dx, sorry, what am I saying? Du dx. We're taking the derivative with u with respect to x. And then dy du is going to be 3u squared. And so that means dy dx is dy du, so which we have, which is 3u squared times du dx, which is cosine of x. And then the final step is to plug back in g of x. So this is 3 sine squared x times cosine of x. Finally, let's do this one. Oh. So now it's sine of x cubed, not sine cubed of x. So now our u, which is g of x, is x cubed, and our y, which is f of u, the outer function, is going to be sine of u. And so du dx, taking the derivative with respect to x, we get 3x squared. Taking the derivative of y with respect to u is cosine u. Therefore, dy dx, taking the derivative with respect to of y with respect to x, is going to be cosine u times 3x squared. And so that's going to be cosine of x cubed, maybe I'll put that in parentheses, times 3x squared. So you'll notice it's the derivative of the outside function evaluated at the inside function times the derivative of the outside function. And so now I'm going to show you how to do it without having to write all this out, just using the fact that it's the derivative of the outside function evaluated at the inside function times the derivative of the outside function. So we're just going to skip a couple steps as we get more comfortable. So the derivative of a composition, you take the derivative of the outside function, plug in the inside function, and then multiply by the derivative of the inside function. So it's essentially the same thing, but we just skip a step. So let's do it. So the derivative of the outside function is 10, and then you plug in the inside function. So it's 6x cubed plus 3x plus 1, and then you subtract 1, so it's to the 9th. And then now we multiply by the derivative of the inside function. So maybe I should write what the outside function, inside functions are. So g of x is 6x cubed plus 3x plus 1. F of x is x to the 10th, or f of u, if you will. Maybe we shouldn't use the same variable so we don't get confused. F of u is u to the 10th. And so f prime of u is 10 u to the 9th, and then g prime of x is, well, I don't know if I want to write it, but I guess I can. I'll move it over and write it. And so then g prime of x. So it's just using the different notation, the prime notation. This will be 18x squared plus 3. And so it's f prime of u evaluated at g of x times g prime of x. And so the derivative, maybe I'll write like this. So this is equal to f prime, which is 10, and then 6x cubed plus 3x plus 1 to the 9th, times g prime, which is 18x squared plus 3. That's the derivative. Do part B. We might want to rewrite this as 5x squared plus 1 to the 1/2 power. And then we're taking the derivative of that. And so what is that equal to? Taking the derivative of the outside function, you bring the 1/2 down, plug in the inside function, which is 5x squared plus 1. Subtract 1 makes this a negative 1/2, and then times the derivative of the inside function. The derivative of the inside function is 10x. And that's it. That's how you do the chain rule. And we'll do another one. This one's a little bit more complicated, so let me write this. So the inside function g of t is slightly more complicated because it itself is a quotient. And so in order to take its derivative, I have to do the quotient rule. And so that's the kind of annoying part. So g prime of t, what is that going to be? It's low d high, so 3t squared plus t, times the derivative of the high, which is 10t. There's no way this is going to fit. I have to put this down here. Minus high, 5t squared d low, which is 6t, all over low squared, 3t squared plus 2. So that's just what g prime of t is. And so to take the derivative of this whole thing, I take the derivative of the outside function, which is the cubed. And so it becomes 3. So the whole derivative, so that's kind of off to the side. The whole derivative will be 3 times the original thing inside, 5t squared over 3t squared plus 2. And then you subtract 1 from the power, so it's squared. And then times, now we got to times it by that whole disgusting thing, which is g prime. And so this is going to be, I'm not going to simplify it. We can just leave it like this. That's totally fine. Minus 5t squared times 6t all over 3, oh, that should be a squared, sorry. 3t squared plus 2 squared. And then that is the answer. And so it's the derivative of the outside function, which is 3, evaluated at the inside function, times the derivative of the inside function. That's the chain rule. And I have space for one more, so let me do this last guy. So we're going to take d dx of e to the minus 3x. The derivative of the outside function is just e to the minus 3x. That doesn't change. And then times the derivative of the inside function, because the derivative of e to the u is just e to the u. And then we multiply by the derivative of the inside function, which is negative 3. And so this becomes negative 3e to the minus 3x. And so in general, this is a nice rule to have. E to the kx, where k is any constant, is just k e to the kx, where k is constant. right? By the chain rule, that will be true. And that's true if you plug in a constant into anything. Sine of a constant times x, you just bring the constant out. And so that's how the chain rule becomes really nice. All right. There's another chain rule power kind of simplification that they say that if you have a function raised to a power where p is a real number, then you can just bring the power down, subtract 1 from the power, and then multiply. And that's really just doing the chain rule, right? Where your u is u, or your f is u to the p. And so here's an example where we use that. So in order to do this, it's first a product, right? It's x squared times that. But I'm going to rewrite it. I'm going to rewrite it as d dx of x squared and then times. I'm going to rewrite this using fractional powers. And we always want to do that because fractional powers are how we can use the power rule. And so this is a product first, and then also a chain rule. And so by the product rule, we do the derivative. If I call this f of x, and I call this g of x, then f prime of x is by the power rule just 2x. What is the derivative of g? G prime of x, because this is a composition, we take the derivative of the outside function, so bring the 1/2 out. So 1/2 x squared plus 1, and then we subtract 1 from the power, right? And so it's negative 1/2, and then times the derivative of the inside function, which is 2x. And so now that we have all those pieces, we're ready to calculate the derivative. And so maybe I'll just put this here. So that is just equal to the derivative of the first guy, 2x, times the regular of the second, which is x squared plus 1 to the 1/2 power. And then plus the regular of the first guy, which is x squared, times the derivative of the second, which is 1/2 x squared plus 1 to the minus 1/2 times 2x. And then that is our final answer. If it asks you to simplify, you can obviously do algebra to simplify it, but for sake of time, we'll just leave it like that. And so this one is where you have to first do the product rule. And so it's that times that, so we're doing the product rule, but then to take the derivative of one piece of the product rule, the g prime, we had to use the chain rule. And so you can combine those rules to take really complicated derivatives. And so let's do one final one that's even more complicated. This one is a function within a function within a function. This is like an f of x, f of g of h of x, right? It's like a double chain rule. And so to take a derivative of something like this, we'll first take the derivative of that guy. Let's first consider the derivative of that guy, and then we'll plug it in. So h of x, the inner function, is cosine of x. G of x, or g of h of x, g of, maybe I guess I'll call it u, is going to be e to the u. H prime of x, so the derivative of h is negative sine of x. And g prime of u is just e to the u. And so that means that the derivative d dx, so g prime so the derivative d dx of e to the cosine x is just going to be the derivative of e to the x, which is e to the evaluated cosine x, and then times the derivative of that guy, which is negative sine of x. So this is negative sine of x, e to the cosine x. So that's the derivative of the inside part. But remember, the chain rule says take the derivative of the outside, plug in the inside, and then multiply by the derivative of the inside. And so the derivative of sine of e to the cosine x, well, we take the derivative of the outside. The derivative of sine is cosine. We evaluate it at the inside, which is e to the cosine x, and then times the derivative of e cosine x, which we just calculated right here, which is negative sine x times e to the cosine x. And so that will be what it is. So you can take a product of a product, or you can take a chain rule of a chain rule. So in general, what is the rule? So in general, how do you take a derivative of a function within a function? D dx of f of g of h of x. So if you have three function compositions, how do you take the derivative? You take the derivative of the outside function, f prime, evaluated at g of h of x, but then times the derivative of the inside function, and the derivative of the inside function is g prime of h of x, but then we need to take the derivative of the inside function again, times h prime of x. Because this is the derivative of g of h of x. And then because the derivative of that, you have to multiply by the inside. And so it's kind of like those like Russian cups or whatever, right? You just got to keep getting out the layers until we get to that final guy. You take the derivative of one guy at a time, f prime of x evaluated at the inside, g prime of x evaluated at the inside, until you get to the final guy. And that's how you do it. And so that should be all you need to get you through the rest of this week's homework. And then, yeah, you should be good. If you have any questions, feel free to reach out, and I'll see you guys soon.